Okay, hello everyone. Uh, in this video, we are going to discuss numericals based upon Fourier integrals. Last class, we have been discussed in detail about Fourier sine and cosine integrals. So this is your Fourier sine integral. Here you can see f of t is considered as a odd function. So if we are going to consider this integral, then this odd it will be a even function. So this integral also can be written as 2 into 0 to infinity. So your 2 by pi 0 to infinity sine omega x d omega 0 to infinity f of t sine omega t dt. Also some books has been written. So you can follow this one, or 2 by pi 0 to infinity 0 to infinity also you can write. Here also same thing, f of t is considered as your even function, so this will be the even function, so this can be written as 2 into 0 to infinity. Okay, now we are going to go for then some numericals based upon Fourier integral. So this is your first question, that express the function fx. Fx is given that fx equal to 0 when x mod less than equal to 1 and 0 when x mod greater than 1 as Fourier integral. Then evaluate this one, 0 to infinity sine lambda into cos lambda x divided by lambda into d lambda. Okay, so we know that the Fourier integral in general form of fx is nothing but 1 by pi 0 to infinity minus infinity to plus infinity f of t cos omega t minus x d omega into dt, that we derived uh, from our integral theorem, this one. Okay, this one. So here we replaced omega as lambda because we have to evaluate this integral. Only for that we replaced omega as lambda. So 1 by pi 0 to infinity minus infinity to infinity f of t cos instead of omega lambda has been written t minus x d lambda dt by replacing omega as lambda. So obviously d omega will be d lambda. Now this f of t, see here we have to use this function here, given that f of x equal to 1, and instead of f of t we have to use these values. So these values is 0 when x mod less than 1. Here you can see that it is given that x mod less than equal to 1. That means this is the equation of x minus 0 mod less than 1. That means center is at 0 and its radius is 1. Radius is 1 means here 1 means here minus 1. So if it is x minus 0 less than 1 means the limit is minus 1 to 1. Okay, so it is given that in between minus 1 to 1 this value is 1, and above that means minus 1 beyond up to minus infinity and 1 be up to my plus infinity, value is 0 0. Okay, so now we are going to use the values. So first we have to segregate the integral minus infinity plus infinity, that minus infinity plus in minus 1 up to this much minus infinity to minus 1. Okay, f of t cos lambda t minus x d lambda dt, then plus minus 1 to plus 1, this up to this limit f of t cos lambda t minus x d lambda dt, and plus 1 to lambda 1 to infinity f of t cos lambda t minus x d lambda dt. So these two integrals will be cancelled out because in between 1 to infinity and minus 1 to minus infinity to 1 has been given as 0. So these two integrals will be cancelled out and this integral will be written here, minus 1 to plus 1 cos lambda t minus x d lambda dt. Already 0 to infinity integration is there, 1 by pi is there. So 1 by pi 0 to infinity, here minus 1 to plus 1 integration with respect to dt and into d lambda. Integration of cos lambda t minus x will be sine lambda t minus x by lambda, minus 1 to plus 1. We have to put the limit instead of t. So here we have to put 1, that will be sine lambda 1 minus x by lambda, minus here we have to put minus 1. So minus 1 minus x by lambda d lambda. Here you can see if I will take the common minus, it will be 1 plus x. So as sine x or sine function is even, so sine minus of lambda 1 plus x will be minus, so it will be plus. Okay, so plus sine lambda 1 plus x. So same thing, it has been written over here. Lambda is in the denominator, 0 to infinity d lambda. Okay. uh, so 1 by pi, 1 by lambda here I have been written. And here you can see sine c plus sine d. Sine c plus sine d means 2 sine c plus d by 2 into cos c minus d by 2. Here you can see 1 by lambda taken outside. Sine c in plus sine d formula is your 2 sine c plus d by 2. So c is your lambda 1 minus x, d lambda 1 plus x. So c plus d by 2 into cos c minus d by 2 formula we have been considered here into d lambda. 1 by pi 0 to infinity, lambda 2 lambda is there, lambda. So here you can see this is your lambda minus lambda x, lambda plus lambda x got cancelled, 2 lambda by 2 is your lambda. Here you can see cos lambda minus lambda x minus lambda again minus lambda x. So lambda lambda got cancelled and minus 2 lambda x will be cos, even function means cos lambda x by 2. So 2 got cancelled. Here you can see minus lambda x again minus lambda x minus 2 lambda x. 2 got cancelled. 2 got cancelled. So as it is even function, we can write cos lambda x by lambda into d lambda. That implies f of x we found 2 by pi sine lambda into cos lambda x by lambda into dx. This is the expression of the Fourier integral form of the given function. Right now we are going to find out this value will be how much. Okay, so this is the f of x equal this one. As per the question, it has been given that f of x equal this one. So f of x in the integral form, Fourier integral form, we found this one. So obviously this value will be equal to this much. This value will be equal to this much. So that implies sine lambda into cos lambda x by lambda into dx. We are going to multiply pi by 2 with this one. So pi by 2 when x mod less than equal to 1 and 0 when x mod greater than 1. So this one is the second question. Find the Fourier sine integral for f of x e to the power minus beta x when beta greater than 0. Then show that pi by 2 into e to the power minus beta x equal to 0 to infinity lambda sine lambda x by beta square plus lambda square into d lambda. From Fourier sine integral, we know that f of x, Fourier sine integral of a function f of x 1 by pi 0 to infinity sine omega x d omega minus infinity plus infinity f of t sine omega t dt. And here f of t is your odd function. Remember, f of t considered as your odd function, right? So 1 by pi 0 to infinity sine, here we considered as omega is your lambda. So lambda x d lambda minus infinity plus e to the minus beta t into sine, instead of omega we have to write lambda t dt, right? So here you can see that as I told that this f of t is considered as your odd function. So this one also considered as odd function. So this minus infinity to plus infinity can be written as 2 into 0 to infinity. Okay, so 2 taken outside, 0 to infinity sine lambda x d lambda is already there, and this integral will be this one. Already I told that you have to remember the 5 important integrals. Here it will be used that e to the power a x. Here you can see e to the power something sine bt like this. So this formula we have to use, that is e to the power x by a square plus b square into a sine bx minus b cos bx here. So e to the power minus bt by b square plus lambda square whole into minus b sine bt, because here it is a sine bt. So here a means here it is minus beta sine lambda t minus lambda cos lambda t, that is a 0 to infinity integration limit. Carefully you have to watch. Here it is minus, I omitted one step here, minus infinity plus infinity, but as we consider that this is your odd function for your Fourier sine integral, this one is your odd function. So this entire will be the even function. So this integral can be written as 2 into 0 to infinity. 2 into 0 to infinity, 2 taken outside, and this integration is this one, and limit is your 0 to infinity. So here I written that f of t considered to be odd function. F of x, that implies 2 by pi 0 to infinity sine lambda x d lambda. Here we have to put the limit infinite. If you have to put over here, this will e to the minus infinite. No need to write other things because e to the minus infinite means it will be 0. So I not written all the other terms. Minus 0 we have to put e to the 0, e to the 0 by beta square plus lambda square whole into here. If I put 0, this value will be 0 minus lambda cos 0 will be 1, right? So e to the minus beta x equal to 2 by pi 0 to infinity sine lambda x dx d lambda. So here you can see this value will be 0, e to the minus infinity, and here minus minus plus e to the 0 is 1, lambda is there, lambda by beta square plus lambda square. So that implies pi by 2 e to the minus beta x, because f of x in our question has been given that e to the minus beta x. So pi by 2 e to the minus beta x equal to 0 to infinity lambda sine lambda x d lambda by b square plus lambda square, hence proved. Now we are going to go for another question, that is your using Fourier cosine integral so that 0 to infinity cos omega x by k square omega square d omega equal to pi e to the minus k x by 2k. Okay, so here is the solution. From Fourier cosine integral, from Fourier cosine integral, in general we know what f of x equal to 1 by pi 0 to infinity cos omega x into d omega minus infinity to plus infinity f of t into cos omega t into dt. I'm going to show you, or you can check your note, that Fourier cosine integral, this one, cos omega x 1 by pi minus infinity plus infinity f of t cos omega t dt. Okay, same thing I have been written. Then here we consider f of t equal to e to the power minus kt. Okay, let f of t equal to e to the power minus kt, right? So that implies f of t, or the so-called f of x instead. F of t we consider e to the minus kx, so corresponding f of x will be e to the power minus kx. So e to the power minus kx equal to 1 by pi 0 to infinity cos omega x d omega minus infinity to plus infinity e to the power minus kt into cos omega t into dt. Here we are going to use the special integration. Okay, as I told that this value will be considered, this function will be considered as even function, so entire function will be even. So this can be written as e to the minus kx equal to 2 into 2 by pi 0 to infinity cos omega x d omega, and this minus infinity plus can be written as 2 into 0 to infinity, 2 written over here, 0 to infinity e to the minus kt into cos omega t into dt. Right, now this integral can be solved by using the special integration, whatever I have been told to you, that you have to remember this one, these 5 integrals. If I will be compare with this e to the minus cos omega t, that means we have to use this one. Okay, e to the ax by a square plus b square, a cos bx plus b sin bx, that we are going to put. So that implies e to the minus kx equal to 2 by pi 0 to infinity cos omega x into d omega into this. So this value will be e to the power minus kt divided by k square plus omega square minus k cos omega t plus omega sin omega t that we have to use the special integration limit. We have to put 0 to infinity. So that implies e to the minus kx. If I will put the limits, then what we can found? We can found that here you can say my infinite means it will be 0. Then if you are going to put the 0, then this value will be e to the 0. Here you can see. So first term will be 0 minus second term. Second term e to the 0 by k square plus omega square into this value will be minus k plus this value will be, if I will put over t over here, sine 0 is 0, right? Okay. So that implies e to the minus kx equal to 2 by pi 0 to infinity cos omega x d omega. Here we found 1 by, this is minus minus plus, so it will be 1 by k square plus omega square into k, actual k by, okay, k by. So that implies what we found this integration cos omega x by k square plus omega square d omega will be equal to pi by 2. Now it has been proved already. 0 to infinity cos omega x by k square plus omega square d omega equal to pi, this pi multiplied pi by 2 into k also multiplied with this one denominator by 2k into e to the power minus kx, what we intend to prove proved, right? Okay, now we are going to go for another question. So next question, it has been given that find the complex form of the Fourier integral of this one. Okay, we have to find out the complex form of this Fourier integral. Okay, solution. In general, complex Fourier integral, complex form of Fourier integral is what? F of x equal to 1 by 2 pi minus infinity to plus infinity e to the power minus I omega x into d omega, then minus infinity to plus infinity f of t into e to the power I omega t into dt. You can check your notes. Previously you have been written and we have been proved also that one, right? Fourier complex integral is this one, e to the I omega x d omega f of t e to the I omega t dt. So same thing, it has been written over here. I written now here f of t as per the question is your e to the power minus kt. F of x kx t means it will be t. F of t e to the minus kt. So that implies f of x will be equal to how much we have to write? Only e to the 1 by 2 pi minus infinity to plus infinity. Instead of f of t we have to write e to the minus kt. Okay, then other things we have to write as such: e to the minus I omega x into d omega minus infinity to plus infinity we have to write instead of k f of t e to the minus kt into e to the I omega t into dt. But this value e to the minus kt is in the limit of it is in the limit of when x greater than 0, that means when t greater than 0, so here the integral will be 0 minus infinity to 0, then 0 to infinity. So when 0 to infinity, this value we have to write. Okay, so I have to write it is 0. Okay, 0 to infinity e to the minus kt e to the I omega t dt. Here I omitted one step. Okay, you can write that here. See, 1 by 2 pi minus infinity to plus infinity e to the minus I omega x d omega, and this integral has to be written as minus infinity to 0 0, instead of f of t will be 0 e to the I omega t into dt plus 0 to infinite, instead of f of t what I written, e to the minus kt into e to the uh, I omega t dt. Okay, so this value will be 0. So this step I have been omitted. Directly I written 0 to infinity e to the minus kt e to the I omega t dt, right? That implies 1 by 2 pi, sorry, f of x, that implies, okay, that implies f of x equal to 1 by 2 pi minus infinity plus infinity e to the I minus I omega x. Now we have to okay, you have to rewrite this like this, e to the 0 to infinity e to the power minus k minus I omega into t dt, right? Okay, that implies f of x equal to 1 by 2 pi minus infinity to plus infinity e to the minus I omega x into d omega. Integrate this one with respect to t, what we can get, we can get e to the minus k uh, minus I omega t by minus k minus of k minus I omega integration from limit from 0 to infinity we have to use. That implies f of x will be equal to 1 by 2 pi minus infinity to plus infinity e to the minus I omega x into d omega. Here you just put the limit infinite. The first term will be e to the minus infinite will be 0 minus then e to the power 0 divided by minus of k minus I omega, right? So finally we found f of x equal to 1 by 2 pi 1 by 2 pi minus infinity to plus infinity e to the power minus I omega x. This will be minus minus plus, so plus k, this term will be plus, so k minus I omega will be remaining and d omega is there. Okay, so this is our final answer, that is the finding the complex form of Fourier integral of this one. Okay, next we are going to go for another question. Okay, so this is the another question, that we have to find the complex form of Fourier integral of this function fx having the value x for x mod less than 1 and 0 x mod greater than 1, as I discussed that x mod less than 1, that means it has been given that x minus 0 mod less than 1, it is a circle equation. If we are going to draw it, its center is at 0 and radius is 1. Radius is 1 means this one. So when we are going to consider x mod less than equal to 1 or x minus 0 less than equal to 1 means all the x value less than equal to 1, that means in between minus 1 to 1 range the value is x. When x mod greater than 0, that means the value minus infinity to minus 1 value is 0 and then plus 1 to plus infinity the value is 0. So this side is 0, this side is 0, and inside this region the value is x. Now we are going to go for the solution of this question. It is very similar with our previous question, right? First we have to write the general form of complex form of Fourier integral. Okay, solution in general complex form of a Fourier integral is your f of x equal to 1 by 2 pi minus infinity to plus infinity e to the minus I omega x. That this form you have to remember always, very much essential. Minus infinity to plus infinity f of t into the e to the minus I omega t into dt. So here the so-called f of t we have to put from this value. So in this limit value is x or t, in this range this value is 0. So we have to write once again with the limit that 1 by 2 pi minus infinity to plus infinity is there, e to the minus I omega x into d omega. So here I am going to segregate minus infinite to minus 1 f of t into e to the I omega t into dt plus, sorry, minus infinity to minus 1. This is minus 1, okay, minus 1. Then minus 1 to plus 1 f of t into e to the I omega t into dt, then plus 1 to plus infinity f of t into e to the uh, I omega t into dt. Okay, so in this limit and in this limit the value is 0, but in this limit minus 1 to plus 1 the value is x. That means instead of f of t we have to put only t. So that implies f of x equal to 1 by 2 pi minus infinity to plus infinity e to the minus I omega x d omega. This value will be 0, f of t 0, this f of t 0, only this one. That means minus 1 to plus 1. Instead of f of t we have to put t into e to the I omega t into dt, right? I omega t into dt. Next, that implies f of x equal to 1 by 2 pi minus infinity to plus e to the minus I omega x into d omega. And this one we have to put the by parts. So this is the first function. This is the first function. Second function, integration of the second function, that is e to the I omega t by I omega. Limit we have to put minus 1 to plus 1, then minus derivative of this one, integration of this one, again integration of this one. So it will be derivative of this one, it will be 1. So e to the power I omega t divided by, first time integration I omega will be divided by I omega, second time integration I square omega square, limit from minus 1 to plus 1. Okay, so that implies f of x equal to 1 by 2 pi minus infinity to plus infinity e to the minus I omega x d omega. Here we have to put the value. Here you can put the value. If you are going to put, then 1, if I will put, this will be 1, then minus of minus 1, it will be plus 1. So it will be 2 by I omega. No, we have to just put the limits. Okay, first put the limit. So it will be e to the I omega t, then minus of e to the minus I omega t divided by I omega. Okay, minus, here I square is your minus 1, though it will be obviously plus. So if I am going to put over here, this will be e to the power only I omega, no, only I omega, not I omega t, only I omega, e to the I omega minus e to the I omega, like this. Here this will be e to the I omega minus e to the minus I omega divided by omega square. Okay, so that implies f of x equal to 1 by 2 pi minus infinity to plus infinity e to the minus I omega x into d omega. So here we can see that this value e to the power I omega minus e to the minus I omega, that means 2 sine 2i sine omega. Okay, because e to the I omega is your cos omega plus I sine omega, then minus of cos omega minus plus I sine omega. Okay, so 2i sine omega. So this value will be 2i sine omega, 2i sine omega by I omega, then plus this value also 2i sine omega by omega square, right? Okay, so that implies f of x will be equal to 2 pi. So here 2y can be taken outside. 2y can be taken outside. So this will be 2y minus infinity to plus infinity, and we found this will be sine omega by I omega plus sine omega by omega square whole into e to the power minus I omega x into d omega. So finally we found this one is the answer, that complex form of Fourier integral of this function, this one. Okay, now we are going to go for the next question. Next question I am going to give you, that you have to do by yourself, right? The question is very similar with this one. The question is find the complex form of a Fourier integral of a function given that f of x has been given that 0 from minus infinity, x varies from minus infinity to minus 1. Then value is x in between minus 1 to 0. Then value is 1 from 0 to x. Okay, 0 to 1, 0 to 1. Then 0 when x is greater than 1. Okay, so you do this question and you can find the answer as, carefully you have to do. Okay, you can find the answer as fx equal to 1 by 2 pi minus infinity to plus infinity e to the minus I omega x d omega, then 1 by I omega 2 cos omega minus 1, then plus 1 by omega square 1 minus e to the power minus I omega. This much answer you can find. Okay, so what is the difference between this question and this question? Here in this question, limit given that minus infinity plus minus 1, then 1 to plus infinity is 0, and in between that it is x. But here in this question, the limit has been given like this, that this is your 0, so minus 1, this is your plus 1, so minus infinity to 1, minus infinity to minus 1, minus infinity to minus 1, value is 0. Then minus 1 to 0, minus 1 to 0, minus 1 to 0 value is x, and 0 to 1 is your 1, and 1 to infinity is your 0. Okay, so extra limit is 0 to 1 has been given as 1. Here you do carefully this question, and the answer of this question will be this one. Okay, do it carefully, and thank you so much for watching this video, and ready for the next class. Next class we are going to discuss about Fourier transform. Okay, so thank you so much for watching this video. Thank you.